This video is for Math 1, Unit 3, Lesson 2, reviewing systems of linear equations. These first two examples are a review of the graphing method. So if we're given equations in slope-intercept form, we can graph the lines and find their intersection. The intersection is the solution to the system. And we can verify that the intersection is the solution to the system by plugging in x and y and verify that the equation is true. For number 2, our second equation is given to us in standard form, but I can easily solve for y to have that equation written in slope-intercept form. And then when I graph both of those lines, we should notice that they have the same slope, which makes the lines parallel, which means they will never intersect. So there is no solution to that system. That's what that 0 with the line through it means. It means no solution. It's not the same thing as 0. So we need to make sure that we have these graphs and these solutions marked. We should have at least 3 points on every line plotted. So for substitution, we have these steps here. First, we're going to pick an equation that is already solved for a variable to be the substitution equation. If there is not an equation set equal to a variable, then solve the easiest to solve equation for the easiest variable. Then we're going to substitute the expression that the variable is equivalent to into the second equation, solve for the remaining variable in the second equation, and then substitute that value back into the first equation and solve for the other variable. Then we'll write our final answer as an ordered pair. So those 5 steps might seem kind of complicated, but once we go through these 2 examples, we should be able to see them a little clearer. So because I'm given x equals for number 3 for both of these, I can set these 2 equations equal to each other. So 4y plus 5 equals 3y minus 2 because both of these equations are equal to x. I'm going to subtract 3y to get y by itself, subtract 5 to isolate y, and I get y equals -7. Then I'm going to substitute -7 into my first equation, x equals 4y plus 5. So I get x equals -23. So my ordered pair xy is -23, -7. For number 4, I'm given y equals x plus 3 and 8x minus 7y equals 12. So here, because I'm given y equals, I'm going to replace y in my second equation with the given value of y, which is x plus 3. So then I have to distribute -7. That's how I get 8x minus 7x minus 21 equals 12. When I combine like terms, I get x minus 21 equals 12. To get x by itself, I need to add 21. So I find x equals 33. When I plug 33 into my first equation to find y, I see that y equals 36, which makes the solution to this system of equations the ordered pair 33, 36. Take a moment to make sure we have all of these steps written down for our equation and make sure that we have our solution in a box. So at the end of this lesson, there will be more examples. Then we have our elimination method. So if we want to eliminate one of the variables, we want to look for a variable with the same coefficient. If they have opposite signs, then we can add them together and they will cancel out. If they have the same sign, I need to multiply one of the equations by -1, which is going to change all of the signs for all of the terms on both sides of the equal sign. Then I can add the equations together and it will cause one of the variables to cancel out, leaving me one variable left to solve for that I can substitute back into one of the equations to find my other variable and give me my ordered pair answer. So for number 5, we see that I have positive x, but I have positive y and negative y. So when I add those equations together, x plus x is 2x, 3 plus 1 is 4, and then 2x equals 4. So I divide by 2 on both sides to find x equals 2. Then I'm going to use x equals 2 to find y. So if x equals 2, that means that 2 plus y equals 3. So when I subtract 2, I find that y equals 1. So my ordered pair solution is 2, 1. For number 6, notice that we have 3x and 3x in the second equation, but they have the same sign. So I need to change all of the signs of my equation on top. So in blue here, I just rewrote my equation so I can add them together. So I get negative 3x minus 4y equals negative 19. Make sure we remember to change the sign of the solution on the opposite side of the equal sign as well in order to make sure that we create an equivalent system. So when I add my equations together now, x's will cancel out. Positive 6 minus 4 is positive 2. So I get 2y equals 14 when I subtract 19 from 33. And I find that y equals 7. When I plug 7 into one of my equations, then I find that x equals negative 3. This gives me the ordered pair solution negative 3, 7. We also have some examples of elimination with multiplication. So sometimes we don't have the same coefficient with opposite signs, and we need to make the equations have the same coefficients with opposite signs. So I may need to multiply one or both of my equations by a number or two different numbers to get the same coefficients with opposite signs. So we're trying to find the least common multiple. And then we're using the same steps from the examples above. So for number 7, we have 2x plus 3y equals 14 and 3x minus 4y equals 4. So if I'm trying to cancel out my y's, because I noticed that my x values both have the same positive sign. So if I want to cancel out x, I'm going to have to multiply one of these equations by a negative number. But if I notice that y, I have positive y in my top equation and negative y in my bottom equation, those are already opposite. So if we want to try and cancel y, we need to think, what is the least common multiple of 3 and 4? And that would be 12. So if I multiply my top equation by 4 and my bottom equation by 3 to get these equivalent equations in blue underneath, I can add them together and my y's will cancel out, giving me 17x equals 68. To solve for x, I divide by 17 to get x equals 4. Then below that, I plug in 4 to find y equals 2. And here in the middle in pink, if I want to check my solution, if I plug in 2 and 4 into both of these equations, I should get a true statement. So 2 times 4 is 8 plus 3 times 2 is 6 equals 14. That's true. 3 times 4 is 12 minus 4 times 2 is 8 equals 4, which is also true. For number 8, notice I have x and y are both either x here is both positive and y's are both negative. So I'm going to have to multiply by negative to change my sign. So if I want to cancel out my x values or my y values, I notice that my least common multiple for x is going to be 6. My least common multiple for y is going to be 12. And I end up getting 6x minus 12 equals 18 and negative 6x plus 12y equals negative 18. So when I add these together, I get 0 equals 0. If I ever have a number equaling itself as my solution, that's going to tell me that this is the same line. These two equations represent the same line. So that's going to mean that I have infinitely many solutions. If I get a situation where, let's say, this ended up being 0 equals 5, then that would mean no solution because that is not a true statement. So pause the video here, make sure we have the notes written down for these examples. And for the remaining examples on this page, we will have a separate video to review them.